Been a really busy couple of weeks here. I've been really busy at my other job. But in my last few videos, I was building a dust collector for my shop. And a lot of people commented wanting me to do a follow-up once I got my plumbing and all done. And I've got most of it done now, and I've done plenty of testing and stuff like that with this thing, and I really like it. It really does vacuum very well. And but I've had to do some modifications. Had a catastrophic failure. I've done some modifications, slight modifications to the Cyclone and to the Impeller itself, and also the way I drive it. So I'm going to go over that stuff with you, and I'm very happy with it now. It runs great, and I can actually use two 4-inch dust ports at the same time, and it pulls really hard through both at the same time. So I'm in good shape there. So anyway, without any further ado, let's go out here and look at this thing right quick. I'll show you the outside first. Alright, first of all, I've got this thing outside, and what you may notice, let me see how far I can zoom back. What you may notice is that I no longer have my pulley up here. Okay, I'm directly driving the impeller from the motor, and I'll explain why I did that later. But I've done some modifications on the top. I added these slats on each side over here to add strength to this, to the very top, so the weight of the motor doesn't push down. Alright, so another modification I made is to the filter box. Let's see if I can get that open. Okay. And if you'll notice, let me get the filters out. The filters are much cleaner now than they were previously. There's not near as much dust actually goes up into the filters. But I installed this little flange here, and it reaches down into my Cyclone about 2.5 inches. So about that far. And what that does is it gives the dust and stuff a chance to get caught by the Cyclone and actually get spun down and around to fall in here, instead of going straight from the intake up into the filters. So now a lot more of the small dust actually gets caught in the receptacle down at the bottom down here. You have to kind of pardon the mud. It's been raining like it's just been cats and dogs here for about the last week, and it's just been really tough. It's like a swamp around my shop out here. But anyway, let me put these filters back in, and I'll talk about the rest of the other modifications that I made. Okay, well, here's my receptacle. And if I push it down and pull the receptacle out, you can see a lot finer dust is getting caught now in the receptacle. And over here, a lot finer dust is getting caught by the receptacle now than previously, because it actually has a chance to go down in there. And let's get that back up there. Okay. And it actually has a chance to get into the receptacle. Well, and that's all due, I believe, to the flange that I put in the filter box that reaches down in there. It just gives that stuff a chance to get going. But I also, down in the bottom, if you remember, I built a baffle to go in there, and it was a cross section type baffle. It stood up, it was 4 inches tall, and I believe that was part of my problem also, because as the air was spinning spinning around this Cyclone here, when it hit that, it did exactly what I was planning for it to do. It would stop the air, but it would cause turbulence, and I believe that was kicking the small dust back up into the filters. So I took that out and I built a thin baffle, and I'll show you a picture of that. You really can't see it right now. It's inside the bottom section of the Cyclone down here, but I'll show you a picture of that. I've already got a picture of it. And what that does, it allows the air to swirl until it gets into the bottom, and then everything falls down into the receptacle. It does, and it slows the air down. It doesn't actually stop it to the point that it causes turbulence. Well, this is the beginning of my plumbing. The top one up here, and there's an ant on it, but the top one up here will be going into the building, or into my shop right about here, to blow the air back into my shop. The air that it sucks out will be going back into the shop, because I have a wood heater, and when you pull air out of the shop, the easiest place for it to get that air is from my flue pipe. So this winter, when I'm burning my wood heater, if I turn on my vacuum, it's going to pull fire and smoke back into the building. It will actually come down the flue pipe, and it won't allow the heater to draft. Okay, well, as my plumbing, what I did, I started at the Cyclone, and I came out of the Cyclone with my plumbing, and I ran it down the side of my building. It's 4-inch. All it is a 4-inch PVC drain pipe. And but anyway, if you notice, I've got wire running around this thing, and what that does is it takes static electricity out of this system and dissipates it, or actually transfers it to ground back into my switch in there. But I've got all the couplings. All my couplings have screws, and these are 1/2-inch screws. They go through the coupling and through the part that goes inside, and they actually stick out to the inside. So theoretically, what's going on here is that as static builds up in this thing, it collects on each screw, and then it's transferred to ground from the wire that's connected to each one. And I wrapped the wire around this thing, just make it look good, I guess. But anyway, we'll walk on down, and I'll show you what I've got here. I have a T right here, and this T is the pipe that goes to my bandsaw. This one goes to my bandsaw. And then as we come on down to this other one, I have to be very careful. Everything's very slippery out here right now. But as we come down to this other, it's an elbow, and it goes in right beside my lathe. All right, so that I can, I've got a dust port right there at my lathe. I am going to come on down and take this elbow out and put a T in and run it on down the side, so I'll have a dust port down on that end of my shop also. So anyway, that's the outside, and that's how I've plumbed the outside, and I'll be back once I get inside. I'll show you what I have in there. Okay, well, the first port that I have is here at my bandsaw. Okay, and I've got my little homemade blast gates here that you can see. They open up, and I can open the air to my bandsaw. I can close it back off if I need to. Okay, and up here I have my switch. All right, once I turn that on, you can hear it fire up. Okay, and this thing really works good around my bandsaw. Let me open it up. You can see the suction actually start to work when you open it up. It really pulls pretty hard. Let me see if you can see that. I don't know, but it just disappears. It's gone. But I'm going to leave that one open because I want to show you just how strong this thing is. Over here I have the one at my lathe. The one in the back here is it's hooked to a, well, right now it's a dryer hose, but it will be a standard duct hose once I get all that stuff in. But right now, just for trying and testing and things like that, I'm just using dryer hose. But anyway, this one goes to the lathe, and this one here will be to my saw, but I haven't got that hose hooked up yet. I'll actually have to go under the floor to get over here to my saw to do that. But I just want to show you how strong this thing is. I wanted it to be able to work two 4-inch dust ports at the same time. So here we go. I'm going to show you that. It's running over here at the bandsaw. That one's open and it's pulling air through the bandsaw. So let me back up here. Now I'm going to go ahead and open this one up and just show you how it picks up dust from the second port. And this thing really pulls good. I mean, I cannot complain. And that's with 2 dust ports open at the same time. Now I'll close the bandsaw off. And it pulls a lot more through here. You can actually hear it now. But I mean, you can hear it. But here we go. We'll try this. I mean, it pulls like nobody's business. But that's mainly due to my other modifications that I had to make. I had to build a new impeller because my other impeller decided to come apart. Alright, let me turn it off. And it's very quiet in here with that thing sitting outside. It's kind of loud outside, but I don't care about that. The neighbors can deal with that. But anyway, I want to talk about a couple of modifications and why I had to do them, and I'll be right back. Okay, why did I have to modify it? Okay, first of all, if you remember on the video, on my build, I built a shaft, and I built it from a 1/2-inch threaded rod with bearings, and I had a bearing block with a bearing on each end and the shaft going through, and that method worked great. I mean, it worked really good until one of the bearings went bad. Okay, well, I didn't want to have to go and try to find better bearings and have to order them online and wait a couple weeks or a week or so for them to come in and things like that, because bearings is very hard to find around this area. So I would probably resort to ordering them online anyway. But what I did was I did an experiment, and I took that 1-horse motor at 3450 RPM and I directly mounted it to the impeller. And so I had to change that a little bit. Instead of having it running through a pulley, turning the shaft, I moved the motor up and let the motor shaft come into the impeller housing, and I ran it that way. All was good, or actually all was great, for about 10 seconds. This thing actually, let me see if I can find it. Well, shoot. When I was doing my repair, there it is. When I was doing my repairs, I had my impeller housing turned upside down with the motor pointing down so that so I could work on the housing and stuff like that. And it was turned upside down on my workbench. And when I turned it on, it blew this 16-ounce hammer across my workbench. Well, I liked that. I really did like that. It was unbelievable, the airflow that I had for the first about 10 seconds or so. At that point in time, the impeller decided it wanted to be in all of its individual parts again, and it exploded inside the housing. Okay, no pieces came out. You know, all the pieces stayed inside the housing, but of course it was kind of scary there for a second because it sounded like a shotgun went off in here. But I had to go back to square one, and I knew that if I wanted to keep that type of airflow, that somehow I was going to have to build a stronger impeller. And actually what happened was the vanes separated from the plywood, not from the glue joint, but the ply on the plywood actually ripped off of the plywood. So I didn't really think about that when I was putting this thing together. It ran great around 2200 RPMs, but when you got up to around 3450, it just couldn't handle it. The plywood just separated. So from the vanes. So what I did, and I was thinking, and fiberglass. Okay, I thought, well, shoot, I will reinforce this thing with fiberglass. So I got some fiberglass and resin, and I built a brand new impeller. But when I built this impeller, I cut my pieces and everything. I actually built it on the lathe, and that's what this waste block is for. I had it hot glued to this waste block, so I could get everything true, get all my my holes perfectly dead center, everything. I didn't even cut the middle out on the scroll saw like I did in a video. I cut it out on the lathe, so that hole is perfectly centered in the middle of that impeller. So I trued everything up, and then I pulled the belt off my lathe so that it could free spin just on the lathe bearings. Okay, and then that is how I balance the impeller. The exact same method that I used in the video, but I just used the lathe bearings instead of the shaft bearings because this one wasn't mounted on the shaft. So got it balanced. But as I was putting this thing together, my first layer, once I got my vanes glued on there, and they were glued on with wood glue, then I went back and fiberglassed all the vanes to the bottom section. Then I fiberglassed the top section with a hole. I fiberglassed it onto the top of the vanes. That's when I mounted it on the lathe. So got everything trued up. The impeller doesn't wobble. It doesn't wobble, and it's balanced very well. The machine out there, it really does not vibrate. I didn't try a nickel test, but I think a nickel might stand up on it. It's about as steady as my bandsaw. So but it doesn't vibrate. Not enough that I'm worried about it anyway. So, and that's pretty much, you know, what happened. Catastrophic failure led into a design opportunity to make something better. And now, instead of running a shaft at 2200 RPMs, I'm running my impeller now at 3450, which is the you know, the rated RPMs of that motor. So, buddy, it pulls air like crazy, and I've got less than $100 in the whole thing. Now, I'm ordering duct hose, and it's not very expensive, but and it's on its way, but it'll be a few more days before it gets here. But really, that's all there is to it. And I've ran it for an hour. I ran it for one solid hour, sitting out there just running to make sure that, of course, the impeller wasn't going to come apart again, or make sure I didn't have any kind of other problems. So anyway, if you look back, if you think you might want to build one of these, you look back through my video. The biggest change was the impeller. I decided to go with a direct drive, you know, and it took out the having to build the shaft and making the pulley and all of that. But if you wanted to build one like that, fiberglass your impeller and get it balanced really well. If you want to try spinning it at these type RPMs, because that is super fast for that thing, but it really pulls a lot of air. I use 6-inch holes everywhere so that I could run 2 4-inch dust ports, and I was hoping that would work. I thought it would work. Mathematically, it works out that way. So, and it does work. It works great. It pulls really good through both sections at the same time. So I can't complain. I've got less than $100 in a Shopmade dust collector that's high capacity, and hey, let's do this. All right. Well, I'm ready to get back to turning and doing some woodwork and things like that. And I've already got my next project. My next video project is right here, and I'm going to be starting on that this evening. And you know, hopefully I'll get that up in the next couple of days or so. But that'll be another video. Hey, y'all have a good evening, and I hope you enjoyed this series on my dust collector. And y'all have a good day. See you on down the road.